Okay, so for our next problem, we are going to take a look at solving for theta. If we know v initial is 25 meters per second, the distance the person is away from the soccer goal is 20 meters, the height of the ball going through is 3 meters, what angles would the person have to kick at to cause the ball to go up and through the goal? And so we start this problem. This problem's going to get a little complex on us. We start the problem by making our data table. We are going to say here that v initial y is equal to 25 cosine theta. V initial x, I should say. V initial x is 25 cosine theta. V initial y is 25 sine theta. Ax is equal to 0. Ay is equal to negative 9.8 meters per second squared. X is equal to 20 meters. Y is equal to 3 meters. And then we're solving for t. What's the t value? Ultimately, what we want theta. That's what we're looking for. T is going to be a byproduct to go through this. So what we want to do here, because we have two unknowns, we only know two pieces of data on each side. We have a theta we don't know, we have t we don't know. And so to figure this out, what we want to do is we want to say, using our second kinematic, x is equal to v initial times time plus 1/2 at squared. We would set this up to say 20 is equal to 25 cosine theta t plus 0, because the acceleration in the x direction is 0, and so you immediately know that term is gone. And we're going to say in the y value that 3 is equal to 25 sine theta t minus 4.9 t squared. Again, half of 9.8, negative 4.9. And so we would solve this for t. Can't really solve it for theta very well. So t is equal to 20 divided by 25 cosine theta. Substitute that in. We're going to substitute that in here and here. And so when we do that, we get 3 is equal to 25 sine theta times, this is the substitution in the brackets, 20 over 25 cosine theta minus 4.9 times, this is the part that makes this challenging, 20 over 25 cosine theta squared. The 25s cancel out. Sine over cosine's tangent. 3 is equal to 20 tangent theta minus, now we get our calculators out and we calculate those values. 4.9 times 20 squared divided by 25 squared. So make sure you remember to square both values. And we end up with 3.136 times secant squared theta. 1 over cosine squared is secant squared. We have a tangent, we have a secant, we need to use a trig identity. Trig identity we're going to use says that the secant squared theta is equal to the tangent squared theta plus 1. So we'll substitute that in there. So we do 3 is equal to 20 tangent theta minus 3.136 times tangent theta plus 1. We do the distribution. So 3 is equal to 20 tangent theta minus 3.136 tangent theta plus 3.136. Sorry, minus the distribution of the negative as well. So minus 3.136. Make sure you distribute the negative 3.136. At this point, we set it equal to 0. And to set it equal to 0, I'm moving everything to the left. You can move it to the right and leave things negative and distribute the negatives. You can do whichever way you want, but you want to get everything on the same side of the problem. And so to get everything on the same side of the problem, I'm moving everything to the left. So I would have here, this is a tangent squared. Drop the square. It's tangent squared. So I'd have 3.136 tangent squared theta minus 20 tangent theta plus 6.136 is equal to 0. And now I know that A is 3.136, B is negative 20, C is 6.136, and X is going to be represented by the tangent of theta. So now we go to our quadratic formula. And so the quadratic formula says to us that the tangent of theta, we would say here, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So the tangent of theta is going to equal negative 20 plus or minus the square root of negative 20 squared minus 4 times 3.16 times c, which is 6.136, all over 2a, which would be 2 times 3.136. And I get the tangent theta equals, and there's two values, a plus and a minus. If you have a scientific calculator, use the scientific calculator. If it's a graphic calculator that can solve this stuff, use it. If you don't have that, then you could always use a quadratic solver. When we plug this in to our values, we get two numbers. 0.32. Okay, and so when we plug that into the solvers, we get those numbers. And then what we need to do is we need to take the arctangent of those values. And so when we take the arctangents of those values, we end up with theta is equal to 80.6 degrees, and we get theta is equal to 17 degrees, something like that. Yeah, so those are the two angles we get. One of those angles goes up, and it's on the way up, and it's going to keep going up. The other one is like this, where it goes up, and then it's coming down. So you have the two different approaches to solving that problem. One is a low angle trajectory, one's a high angle trajectory. The times to get there would be different. Each would have their own time value. You could plug them back in here to get the time, and each would have a different velocity as it's traveling through the goal. The velocity would be equal and the velocity that's actually traveling through the goal depends on a couple factors, but as it gets to that point, you're going to see some differences because of the trajectory it went. So if you have any questions, let me know.